Look around you. Everything you see, everything you touch, and everything you feel seems to exist in a flawless, unbroken stream of moments. We call it time. We treat it as the ultimate ruler of the universe, an invisible river flowing from a distant past, through the fragile needle eye of the present and into an infinite future. But what if this river is nothing more than a ghost, a grand illusion generated by the limitations of human perception? For centuries, classical physics taught us that time is absolute. Sir Isaac Newton envisioned it as a cosmic clock, ticking away at the exact same pace across the entire universe, completely independent of space, matter, or anyone watching. In this classical world, the past is gone forever, the future is yet to happen, and the now is a universal truth shared by every star, every planet, and every human being. It is an intuitive world, it is a comfortable world, and it is completely wrong. To truly understand how time dissolves, we must first look at the only law in all of physics that gives time a direction, the arrow of heat. Think about the things you observe every day. A cup of hot coffee left on a table slowly cools down. It never gathers heat from the surrounding air to boil again. A pristine glass vase falls from a table and shatters into 1,000 chaotic pieces. You will never see those shards pull themselves back together and fly back onto the table. Why does the universe look like a one-way street? The answer was discovered not by looking at the stars, but by looking at the microscopic chaos of steam engines. 19th century physicists like Rudolf Clausius and Ludwig Boltzmann discovered a terrifying and beautiful concept: entropy. Entropy is the measure of disorder. The laws of thermodynamics state that in any isolated system, entropy must always increase. The universe, it turns out, moves inexorably from a state of perfect, elegant order to a state of chaotic probability. Ludwig Boltzmann made a radical proposition. He suggested that the forward flow of time is not an intrinsic property of space itself. Instead, the arrow of time is born entirely from heat and probability. At the microscopic level, among individual atoms and fundamental particles, the laws of physics do not care about time. If you film a collision between two pristine atoms and play it backward, the physics looks absolutely identical. There is no past, and there is no future in the grammar of the quantum world. Time only emerges when we view the universe in macro vision. When trillions of atoms mix, blend, and disperse, they naturally move from rare, orderly arrangements to common, disorderly ones. A drop of red dye in a glass of clear water slowly expands, turning the water into a uniform pink cloud. The dye molecules don't move forward in time. They simply explore the space of chaotic probability. Our brains, trapped in this macroscopic perspective, perceive this shift from order to disorder as the passage of time. If there is no heat transfer, if there is no change in entropy, the clock simply ceases to have meaning. But this was only the first fracture in the monument of absolute time. At the turn of the 20th century, a young patent clerk named Albert Einstein looked out at the universe and tore Newton's cosmic clock to pieces. Einstein realized that space and time are not separate stages where the universe plays out its drama. They are woven together into a dynamic, flexible fabric, spacetime. And this fabric can be stretched, warped, and compressed by the two heaviest forces in existence, speed and gravity. Einstein's special relativity revealed a shocking truth. There is no such thing as a universal now. Imagine two identical twin brothers holding ultra-precise atomic clocks. One brother stays on Earth while the other steps into a high-tech rocket and accelerates to relativistic speeds near the speed of light. As the rocket cuts through the cosmic fabric, the very geometry of spacetime compresses around it. To the brother inside the ship, his clock ticks normally. His heart beats normally. But when he returns to Earth, he discovers a terrifying reality. While only a few months pass for him, decades have bled away for his brother on Earth. This is not a mathematical trick. It is a literal distortion of reality. The faster you move through space, the slower you move through time. Time becomes a local experience, entirely dependent on your frame of reference. The concept of a simultaneous present across the cosmos vanishes into nothingness. The now on Earth is not the now near the center of the Milky Way, and it never will be. Gravity distorts this reality even further. Massive cosmic objects, stars, planets, and galaxies, do not just sit in space. Their immense mass creates deep, heavy funnels in the space-time fabric. They pull space downward, and with it, they slow the rhythm of time itself. If you live at the base of a massive mountain, your clock ticks microscopically slower than the clock of someone living at the misty peak. Time runs faster where gravity is weak and crawls where gravity is strong. We see this every day in our modern world. The satellites orbiting Earth to power our navigation systems exist in a weaker gravity field and move at high speeds. Because of this, their internal atomic clocks run slightly faster than the clocks on the ground. If computer systems did not constantly apply Einstein's equations to correct this time gap, our global navigation maps would drift by kilometers every single day. The universe forces us to accept that time is elastic, fluid, and profoundly fragmented. As we push this logic to its absolute extreme, we find ourselves staring into the deep, dark abysses of the cosmos. Black holes. A black hole is a point where matter becomes so unimaginably dense that the gravitational funnel becomes infinitely deep. The fabric of space-time is pulled so taut that it snaps. If you were to watch an astronaut fall toward the event horizon, the point of no return, you would witness something spectacular and disturbing. As they approach the boundary, the intense gravity causes their time to stretch to infinity. To your eyes, their movement slows down, freezing completely at the edge of the dark sphere. They become a permanent, motionless ghost etched onto the horizon. But for the astronaut crossing that threshold, their local experience is entirely different. They fall straight through, plunging into an impossible geometry where space and time swap their roles. Inside a black hole, moving forward in time becomes as mathematically inevitable as moving forward in space. You can no more escape tomorrow than you can escape the singularity at the center. Here, at the edge of physics, time as we know it ceases to function, giving way to a reality we are only beginning to decode. To find the true nature of time, we cannot just look at the cosmic giants like black holes and galaxies. We must reverse our vision entirely. We must zoom in past the cells, past the chemical bonds, past the atoms, and dive deep into the subatomic landscape ruled by quantum mechanics. Here in the micro realm, our everyday understanding of reality dissolves into a ghost world of probabilities. And it is here that the concept of a smooth, continuous flow of time faces its greatest crisis. In our daily lives, time feels perfectly fluid. It seems to glide seamlessly from one millisecond to the next, like water down a stream. But modern physics suggests this smoothness is another illusion born of our clumsy, large-scale perception. Just as a digital photograph looks like a smooth, continuous image from a distance, but breaks down into individual, hard pixel blocks when you zoom in close, time itself might be pixelated. Theoretical physics has established a fundamental limit to the geometry of our universe, the Planck scale. Named after the physicist Max Planck, this scale dictates the absolute smallest possible measurements of reality. There is a cosmic minimum distance, known as the Planck length, and consequently, there is a cosmic minimum duration of time, known as the Planck time. The Planck time is unimaginably short. It is roughly 10 to the minus 43 seconds. To put this in perspective, there are more Planck moments in a single second of your life than there have been seconds since the Big Bang occurred 14 billion years ago. It is the shortest possible tick of the cosmic clock. Physics tells us that it is mathematically impossible for any change to occur between one Planck tick and the next. Time does not flow, it jumps. Reality stutters from one static configuration to another, flashing in and out of existence at a rate our minds cannot comprehend. When we reach this ultimate microscopic boundary, the smooth fabric of Einstein's spacetime completely disintegrates. At the Planck scale, the universe enters a state of absolute chaos known as quantum foam. Because of the Heisenberg uncertainty principle, energy fluctuations at this microscopic level become so violent that they warp and tear space and time into a chaotic, bubbling soup. Virtual particles pop into existence and vanish in a flash. The concepts of before and after, left and right, up and down, lose all coherent meaning. In this quantum foam, a radical theory emerges: loop quantum gravity. This framework attempts to unite the physics of the very large with the physics of the very small. According to loop quantum gravity, space is not an empty container or a smooth sheet. Instead, it is constructed from tiny interlocking loops of gravitational force. These loops are woven together like the threads of a fabric, creating a shifting, dynamic network. And what happens to time in this network? The answer is staggering. It disappears entirely. In the fundamental equations of loop quantum gravity, there is no variable for time. The universe at its deepest, most fundamental level is completely timeless. What we perceive as time is merely the changing relationships and geometry between these microscopic quantum loops. There is no background clock ticking away. There is only a vast interconnected web of spatial relations constantly rearranging itself. This brings us to a mind-bending philosophical and physical realization: non-locality. In the quantum world, particles can become entangled. When two subatomic particles are entangled, their states become linked across space. Change the state of one particle on Earth, and the other particle on the opposite side of the galaxy changes its state instantly, faster than the speed of light. Einstein famously called this phenomenon spooky action at a distance, because it seemed to violate his rule that nothing can travel faster than light. But it only violates that rule if we assume that space and time are absolute barriers separating these particles. If time and space are emergent illusions created by a deeper, timeless quantum network, then the two particles were never truly separated at all. They are nodes in a single unified system that exists outside the prison of linear time. Our brains are hardwired to sequence events. We survive by remembering what happened yesterday to predict what will happen tomorrow. But the quantum foam shows us that this sequencing is a biological filter. We are like spectators watching a film. We see a hero running across the screen in a smooth cinematic sequence. But if we stand up and walk right next to the projection screen, we see that there is no motion at all. There are only static, individual celluloid frames flashing through a beam of light. The motion, the story, and the time are all generated inside the observer's eye. As we look deeper into this timeless foundation, we must ask ourselves how a universe made of static, timeless quantum loops manages to create the vibrant, changing world we see when we open our eyes. How does nothingness give birth to history? To answer that, we must look at how space, matter, and consciousness interact to create the ultimate construct of human existence: the present moment. If fundamental reality is built from timeless quantum loops and chaotic foam, we face a massive paradox. Why do we experience a distinct, burning reality called the present moment? Why does the universe feel like an unfolding story? To bridge the gap between the frozen quantum world and our dynamic reality, we must look at the macro structures of the cosmos: galaxies, cosmic filaments, and the global network of matter. It is within these colossal systems that time begins to emerge, crystallization by crystallization. Think of the universe as a vast, dark ocean. At the bottom of this ocean, down at the Planck scale, the water is a chaotic soup of individual molecules with no direction. But as we move up to the surface, large currents form. Waves crash, tides pull. These massive movements are what we perceive as cosmic evolution. The cosmic web, the largest known structure in the universe, is an intricate, glowing lattice of dark matter and gas stretching across billions of light years. Trillions of galaxies hang on this web like dewdrops on a spider's thread. As gravity pulls matter together along these filaments, it creates localized pockets of high density. In these regions, stars ignite, planets condense, and heat transfer begins. As we discovered through entropy, where there is heat transfer, there is a change in disorder. And where there is a change in disorder, the direction of time is born. The cosmic web acts as a massive generator of entropy, turning raw, orderly, primordial energy into highly complex, chaotic stellar systems. Time emerges from the collective behavior of trillions of stars, pulsing out into the void. But this emergence brings us to a shocking conclusion. Time is not an object you can find. It is a relationship. It is a biological and physical filter. In physics, this is described by the concept of thermal time. The universe does not possess an intrinsic clock. Instead, we perceive time because we only see a blurred, macroscopic view of reality. If we could see every single atom, every quantum loop, and every subatomic state perfectly, change would cease to exist. Everything would simply exist simultaneously in a massive, multidimensional matrix of probabilities. But because our brains can only register large clusters of matter, we see a blur. We see a sequence. We see time. This blurred perception creates what we call the present. But if you travel across the cosmic web, you quickly realize that the present is completely fractured. Because light has a cosmic speed limit, looking out into deep space is exactly the same as looking back into deep history. When you look at the moon, you see it as it was 1.3 seconds ago. When you look at the sun, you see it as it was 8 minutes ago. The light from the nearest star system, Alpha Centauri, takes over 4 years to reach your eyes. And when our telescopes capture images of distant swirling galaxies on the edge of the cosmic web, we are looking at light that left those stars over 13 billion years ago, long before the Earth even existed. This means the night sky is not a snapshot of the universe as it exists right now. It is a beautiful, chaotic collage of different historical eras, all bleeding into your eyes at the exact same moment. If a civilization living in a distant galaxy were looking at Earth through an incredibly powerful telescope right now, they would not see our modern cities. They would see dinosaurs roaming the landscape or a molten planet cooling down. Who is right? Which moment is the true present? Both are, and neither is. The universe does not have a single universal calendar. Every point in the cosmic web carries its own unique clock, ticking at its own pace, determined by its speed and the heavy pull of local gravity. This brings us to one of the most beautiful and terrifying ideas in modern cosmology, the block universe. Born from the mathematics of Einstein's relativity, the block universe theory suggests that the past, the present, and the future all exist simultaneously in a four-dimensional block of spacetime. In this view, your birth, your childhood, the exact moment you are experiencing right now, and the distant future of the universe are all equally real, solid, and permanent. To a being standing outside of our space-time dimension, the universe would look like a giant frozen sculpture of light and matter. They would see the entire timeline of a star system from its birth in a nebula to its death as a black hole, as a single continuous geometric shape. The passage of time is nothing more than a localized perspective, a spotlight moving along the tracks of a pre-existing landscape. The past is not dead, and the future is not empty. They are simply sitting in a different part of the cosmic architecture, waiting to be observed. As the cosmic web continues to expand, driven by the mysterious push of dark energy, the distances between galaxies grow larger. The filaments of the universal web stretch and fray. Stars burn through their nuclear fuel, radiating heat into the cold, empty vacuum. The universe is moving toward a state of maximum entropy, a point where all energy will be evenly distributed and all temperatures will equalize. When that happens, there will be no more heat transfer, no more chemical reactions, and no more structural changes. Without change, the concept of time will dissolve once again. The cosmic clock will not stop, rather it will lose all physical meaning. The universe will return to the same quiet, timeless state from which it emerged. But before we reach that cold, distant horizon, we must look at the most complex structure ever created by the cosmic web, the human brain. How does this 3-pound mass of neurons translate a timeless, four-dimensional block universe into the vivid, emotional experience of a passing life? We have traveled from the crushing gravity of black holes to the bubbling chaos of the quantum foam and across the vast filaments of the cosmic web. Yet the most mysterious timekeeping mechanism in the known universe is not a star or a quantum loop. It is the 3-pound mass of gray matter resting inside your skull. The human brain is, fundamentally, a biological time machine. It is a biological construct specifically evolved to take a timeless, four-dimensional block universe and translate it into a linear narrative of past, present, and future. At the fundamental physical level, your brain is part of the macroscopic world. It is a highly complex thermodynamic engine made of billions of neurons, consuming energy and generating heat. Because it generates heat, it is bound by the law of entropy. This means that inside your brain, The arrow of time points firmly in one direction. Your neurons can only form memories of events that have already increased the entropy of the universe. You can remember the vase breaking, but you can never remember it flying back onto the table. Memory is nothing more than a physical record of thermodynamic change written in electrochemical patterns. But the brain does not just passively record time, it actively constructs it. The present moment that you feel right now is not an instantaneous flash. It takes time for sensory data to travel from your body to your mind. When you touch an object with your foot, that signal takes significantly longer to reach your brain than a visual signal entering your eyes. Furthermore, your brain processes light, sound, and touch at completely different speeds. Light travels faster than sound, and your visual cortex processes data differently than your auditory cortex. If your brain did not intervene, your reality would be a chaotic, out-of-sync mess of sights, sounds, and sensations. To fix this, your brain delays your perception. It holds on to faster signals, waits for the slower ones to arrive, and then edits them together into a single, synchronized package. This means that what you experience as now is actually a carefully manufactured illusion that happened roughly 80 milliseconds ago. You are permanently living in the past, viewing a beautifully edited tape of reality. This biological construction of time is incredibly fragile. It can be stretched, compressed, and distorted by your internal chemistry and emotional states. When you are in a state of extreme fear or adrenaline, such as a car accident or a fall, your brain's survival mechanisms kick into overdrive. A structure called the amygdala fires rapidly, recording memories with much higher density and detail than normal. When you look back at that event later, your brain reads this massive mountain of detailed data and interprets it as a long period of time. To your memory, the accident happened in slow motion. Time stretched because your brain packed more reality into a single second. The opposite happens as we age. When you are a child, every experience is brand new. Your brain is constantly working at maximum capacity to process, decode, and store unfamiliar patterns. Because everything is highly detailed, childhood summers feel like they last for an eternity. But as you grow older, the world becomes predictable. Your brain builds internal models and shortcuts to save energy. It stops recording the mundane details of everyday life. Because there is less new data being written into your memory banks, years seem to accelerate, slipping through your fingers like sand. Time literally speeds up when the universe loses its novelty. This brings us to the deepest paradox of human consciousness. Through the lens of physics, the past, present, and future exist simultaneously in the block universe. Einstein famously wrote that the distinction between past, present, and future is only a stubbornly persistent illusion. If physics is correct, then your consciousness is like a flashlight moving through a dark, pre-existing mansion. The rooms behind you are not destroyed when you leave them, and the rooms ahead of you are already built. Your brain creates the sensation of the flow of time because it is trapped inside the mechanism of its own biology. We are linear storytellers navigating a nonlinear cosmos. We use the illusion of time to build identity, to feel love, to experience regret, and to plan for survival. Without the brain's ability to sequence the timeless universe, there would be no grief, no hope, and no history. Consciousness is the mechanism by which the universe experiences its own geometry. But what happens when we look beyond humanity? What happens to time when the universe itself reaches its ultimate conclusion? To truly understand how this entire four-dimensional tapestry was woven, we must push our biological time machine all the way back to the ultimate boundary wall of reality. We must travel 14 billion years into the past, to the event we call the Big Bang. In the popular imagination, the Big Bang is envisioned as a colossal explosion, a blinding flash of fire erupting into a vast, empty room of pre-existing darkness. But physics tells us a completely different story. There was no empty room, there was no pre-existing darkness, and most importantly, there was no time before the beginning. Einstein's equations of general relativity force us to accept that space and time are not independent stages. They are tied directly to the matter and energy within them. As we trace the expansion of our universe backward, galaxies move closer together, stars dissolve into raw plasma, and the density of the cosmos rises to infinity. At the absolute starting point, the entire fabric of spacetime is compressed into a single, mathematical point of infinite density and heat, a singularity. At this singularity, the geometry of spacetime curves infinitely sharply. And when geometry becomes infinitely sharp, the equations of physics break down completely. Time ceases to have a direction, a duration, or a meaning. Asking what happened before the Big Bang is a fundamentally meaningless question. It is exactly like standing at the absolute south pole of the Earth and asking which way is south. There is no south of the South Pole because the geometry of the coordinate system terminates there. In the exact same way, there is no before the Big Bang because time itself was born inside the expansion. But how can something be born out of absolute timelessness? This is where the standard model of cosmology meets the bizarre world of quantum mechanics. Some theoretical physicists suggest that the early universe experienced a state known as cosmic inflation. In a fraction of a microsecond, a strange quantum energy field drove the universe to expand exponentially, stretching the microscopic quantum foam into a macroscopic universe. During this violent expansion, the tiny chaotic quantum fluctuations, the bubbles and ripples of the primordial foam, were suddenly stretched across millions of light years. These microscopic irregularities became the massive cosmic seeds of our universe. The regions that were slightly denser with quantum energy attracted more gas through gravity, eventually growing into the cosmic web, the galaxies, the stars, and everything we see today. You are quite literally looking at amplified quantum noise whenever you look up at the starry night sky. As inflation slowed down, this raw energy flooded the newly birthed space-time fabric, creating an incredibly hot, dense, and orderly soup of fundamental particles. This was the moment of lowest entropy in the history of the cosmos. The universe began its existence in a state of nearly perfect organization, and it is this pristine initial order that set the cosmic clock in motion. Like a giant spring that was wound up tight at the moment of creation, the universe has been unwinding ever at a momenta, steadily sliding down the slope of probability from order to absolute chaos. This brings us to a deep and unsettling realization about the nature of our cosmic history. We look back at the Big Bang as an event that occurred in the distant past, separated from us by billions of linear years. But if the block universe theory is correct, the Big Bang is not gone. It is not a memory. It is a permanent, static feature of our four-dimensional space-time architecture. The beginning of the universe is simply the sharp, tapered point of a giant cosmic cone. It exists out there in the geometry of reality, permanently frozen, permanently radiating energy, just as the distant future exists permanently at the wide, expanding base of the cone. We are trapped in the middle of this geometric structure, watching the shadows change on the wall, believing that the past is disappearing and the future is being created. But the cosmos does not create. It simply is. The illusion of a beginning and an end is a local symptom of our journey through the grid. But what lies at the other end of this giant geometric cone? What happens when the cosmic spring finally unwinds completely and the orderly energy of the Big Bang is entirely spent? Episode 6. The Architecture of Cosmic Archives. Every star that burns in the deep vacuum of space, every galaxy that spins along the filaments of the cosmic web, and every human being walking the surface of a planet acts as a biological archive. We are all cosmic machines designed to register, process, and radiate information. In the vocabulary of modern physics, information is not just text or numbers. It is the specific arrangement of matter and energy that allows one state of the universe to be distinguished from another. And the preservation of this information is one of the most sacred principles in all of science. According to the laws of quantum mechanics, information can never be truly destroyed. If you burn a book, the text disappears from your sight, but the information is technically still there. Every atom of carbon in the ash, every molecule of smoke, and every photon of light radiated by the flame carries a microscopic trace of the original pages. If you had an omniscient computer that could track every single subatomic particle in the universe, you could mathematically reverse the smoke and ash to reconstruct the book perfectly, word for word. The past is permanently written into the microscopic state of the present. But there is one place in the cosmos where this sacred law of physics faces its absolute ultimate challenge: the event horizon of a black hole. When matter falls into a black hole, it is crushed into the central singularity, stripped of its structure, and hidden from the rest of the universe. In the late 20th century, the brilliant physicist Stephen Hawking discovered that black holes are not completely black. Due to quantum effects near the event horizon, they slowly emit a faint stream of radiation, known today as Hawking radiation. This discovery led to a terrifying paradox: the black hole information paradox. Hawking's early calculations suggested that this radiation is completely thermal and random. It carries absolutely no information about the matter that fell inside. Over trillions of years, as a black hole slowly evaporates through Hawking radiation, it will eventually vanish completely from the universe, leaving behind nothing but a featureless cloud of random heat. If Hawking was correct, then a black hole is a cosmic eraser that completely destroys quantum information. If you throw a book into a black hole, the information is not just scrambled, it is fundamentally wiped out from existence. But if information can be destroyed, then the foundational principles of quantum mechanics collapse. The past can no longer be mathematically linked to the present, and the entire predictive power of physics falls apart. The universe becomes deeply lawless. To solve this existential crisis, physicists like Leonard Susskind proposed a mind-bending alternative known as the holographic principle. Susskind suggested that when an object falls into a black hole, its information does not actually sink into the interior. Instead, as the object approaches the event horizon, its three-dimensional data is stretched and flattened, encoded onto the two-dimensional surface of the horizon like a giant cosmic hologram. The inside of the black hole is an illusion. Everything is stored on the boundary wall. As the black hole evaporates, the Hawking radiation carries this encoded surface information back out into the wide universe. The information is saved, but the cost is staggering. The holographic principle implies that our entire three-dimensional reality, the space we walk through, the stars we see, and the passage of time we feel, might be nothing more than a projection. We could be a three-dimensional holographic illusion generated by quantum data bits sitting on a massive, distant two-dimensional boundary at the very edge of the observable universe. If this is true, then time itself does not exist in the way we perceive it. The past, present, and future are not events unfolding in a deep three-dimensional room. They are the calculated outputs of a cosmic computer running software encoded on the surface of reality. The universe is an information network, processing data bits at the speed of light, translating the static geometry of a quantum matrix into the vivid, moving experience of a conscious life. And as this computer runs its programs, it steadily approaches its final, definitive calculation. Episode 7: The Ghost System and the End of Dynamics. As we look out across the modern cosmos, we see a universe that is incredibly active, vibrant, and dynamic. Stars are exploding, black holes are merging, and intelligent life is looking up at the night sky, trying to decode the laws of existence. But this era of light and activity is an anomaly. It is a brief, fleeting flash in the long, dark history of the cosmos. The universe is expanding at an accelerating rate, driven by the invisible, repulsive force of dark energy. And this expansion is pushing reality toward a definitive, quiet end. Trillions of years from now, the night sky will look completely different. The acceleration of dark energy will push distant galaxies away from each other faster than the speed of light. One by one, the grand spiral galaxies of the cosmic web will slip behind the cosmic horizon, isolated from each other by valleys of absolute nothingness. Future astronomers living on planets orbiting ancient stars will look out into the void and see nothing but darkness. The cosmic web will fray, dissolve, and disappear from sight. Inside the isolated galaxy clusters, the raw materials for stellar life will slowly run dry. The vast gas clouds that once birthed generations of vibrant stars will be completely consumed. The bright blue supergiants will die out first, followed by the yellow stars like our sun. Eventually, the only objects left burning will be the small, cold, red dwarfs, rationing their nuclear fuel over trillions of years. But even their fires must eventually burn out. By the year 100 trillion, the universe will enter the era of degenerate matter. The cosmos will become a vast freezing graveyard populated by dead stellar remnants, white dwarfs, neutron stars, and cold black dwarfs. These dead bodies will drift aimlessly through an increasingly empty space, occasionally colliding to form brief flashes of light before sinking back into the freezing dark. Eventually, even the solid matter we take for granted will begin to dissolve. Many modern physicists suspect that protons, the fundamental building blocks of atomic nuclei, are not permanently stable. Over unimaginable periods of time, protons will slowly decay, breaking down into individual electrons, positrons, and light packets. The solid rocks of dead planets, the iron cores of dead stars, and the grand monuments of ancient civilizations will quietly evaporate into a thin, featureless gas of subatomic particles drifting through an infinite void. The only massive structures left in this evaporated universe will be the supermassive black holes. They will reign supreme over an empty cosmos, slowly sweeping up the remaining stray particles of light and matter. For periods of time so vast that human numbers cannot easily describe them, the universe will look like a collection of dark, silent monsters resting in absolute nothingness. But as Stephen Hawking discovered, even black holes are not immortal. Through the agonizingly slow process of Hawking radiation, the black holes will begin to lose their mass. A black hole with the mass of our sun will take 10 to the 67 years to evaporate. The supermassive monsters at the centers of galaxies will take 10 to the 100 years. One by one, with a final violent burst of gamma radiation, the black holes will explode and vanish into the vacuum. When the final black hole evaporates, the universe enters its ultimate definitive phase, the heat death. The cosmos will be completely empty, cold, and uniform. It will be a vast ocean of low-energy photons and electrons, separated by trillions of light-years of empty space. Never interacting, never colliding, the temperature of the entire universe will be perfectly equalized, sitting just a fraction of a degree above absolute zero. At this point, entropy will have reached its absolute maximum value. There will be no more energy gradients, no more heat transfer, and no more structural changes. Every point in space will look exactly identical to every other point. And here, at the end of everything, the ultimate truth of time is revealed. Without change, without movement, and without information processing, time loses its entire physical definition. The cosmic clock does not freeze. Rather, the concept of a tick ceases to exist. The universe returns to the exact same quiet, static, and timeless state from which it emerged 14 billion years ago. The circle closes, leaving behind an infinite empty monument of pure geometry. When the universe reaches the state of absolute heat death, it becomes a system in perfect thermodynamic equilibrium. To a human observer, if one could exist, this era looks like a completely frozen, dead void where nothing ever happens. But if we apply the strict laws of quantum mechanics to this infinite emptiness, a terrifying and bizarre phenomenon begins to take shape. In a universe with no stars, no planets, and no biological life, the timeless grid can still generate ghosts. In a state of maximum entropy, everything is completely randomized. The low-energy photons and electrons drift through space like a thin, uniform mist. But quantum mechanics dictates that at the subatomic scale, particles are never truly still. They are governed by quantum fluctuations, momentary random spikes of energy that borrow existence from the vacuum itself. In an infinite amount of time, random chance dictates that these fluctuations will occasionally align in highly unusual patterns. Most of the time, these quantum fluctuations create nothing more than a temporary atom of hydrogen that immediately dissolves back into the void. But if you wait long enough, over vast cosmic timescales that stagger the imagination, something much larger can happen. Through sheer mathematical probability, a group of particles can spontaneously assemble into a highly complex structured object. This is the concept of the Boltzmann brain. Named after Ludwig Boltzmann, this thought experiment suggests that it is statistically possible for a fully formed, conscious brain to spontaneously materialize out of the vacuum of a dead universe. This brain would pop into existence for a split second, complete with false memories of a childhood, a home planet, and a life that never actually existed. It would open its eyes to the cold, empty void, experience a single flash of absolute terror and confusion, and then immediately evaporate back into the dark thermal soup. This concept forces us to look at the relationship between mind and time with a sense of cosmic irony. In a dead universe where the macroscopic arrow of time has completely vanished, localized bubbles of consciousness can still blink in and out of reality like cosmic sparks. To that isolated Boltzmann brain, time exists for a single microsecond. It experiences a present moment, a desperate attempt to sequence its thoughts, and a sudden end. The existence of these random observers raises a profound question about our own reality. How do we know that we are not Boltzmann brains right now? How do we know that our memories of yesterday, our scientific records of a 14-billion-year-old cosmos, and our plans for tomorrow are real? From a perspective of pure probability, it takes far less energy for the universe to spontaneously generate a single brain with false memories of a universe than it does to maintain a massive, real four-dimensional cosmos over billions of years. But whether our history is real or a random quantum hallucination, it highlights the ultimate power of consciousness over the fabric of spacetime. Time cannot exist in a vacuum without an observer to witness the change. A universe with no minds to record its transitions is a universe that is functionally frozen in place. We are the engines that turn raw mathematical probabilities into a living history. But what if this entire system is just one cycle in a grander, multi-dimensional engine? What if the end of time is merely a mask for a new beginning? As we look at the cold, flat horizon of the heat death, it seems like the definitive end of the cosmic script. But some of the most brilliant minds in modern mathematical physics refuse to let the story end in absolute nothingness. Sir Roger Penrose proposed a radical and elegant geometric theory known as conformal cyclic cosmology. This framework suggests that the ultimate end of an expanding universe is mathematically identical to the absolute beginning of a new one. To understand this mind-bending connection, we must look at what happens to the concepts of scale and distance in a completely empty universe. In the final phases of heat death, all massive particles, protons, electrons, and dark matter, have completely decayed. The universe is populated entirely by photons, which are fundamental packets of light energy. Photons are completely massless. They travel at the absolute speed of light, and because they have no mass, they do not experience the passage of time or the scale of space. For a photon, there is no difference between a millimeter and a billion light years. There is no difference between a second and a trillion years. When the universe is filled exclusively with massless light, the geometric markers that define scale and size completely vanish. The universe becomes physically incapable of tracking how large or how old it is. The concepts of big and small lose all physical meaning. Penrose pointed out that if you take a massive, infinitely expanded universe with no sense of scale and mathematically rescaled its geometry, it becomes completely indistinguishable from an infinitely small, dense singularity. The geometry of the ultimate future matches the geometry of the primordial past. The wide, expanding mouth of our cosmic cone can be mapped perfectly onto the sharp, tapered point of a newborn universe's Big Bang. According to conformal cyclic cosmology, our universe is just one individual cycle, an aeon, in an infinite, eternal chain of universes. When our universe expands into the cold, timeless void of heat death, it naturally resets. The timelessness of the photon era allows the universe to lose its memory of scale, triggering a new inflation, a new low-entropy state, and a brand new Big Bang. The end of our cosmic timeline becomes the cradle for the next generation of stars. If this theory is correct, it changes our entire understanding of cosmic heritage. We are not living in an isolated flash of light surrounded by eternal darkness. We are riding a wave in an infinite cosmic ocean that has crashed and reformed a trillion times before, and will crash and reform a trillion times again. Time is not a straight line stretching from a single beginning to a single end. It is a vast, multidimensional helix, cycling through phases of order, complexity, chaos, and rebirth. As we look up at the cosmic web today, We might actually be seeing the ghosts of the universes that existed before our own. Penrose suggests that when supermassive black holes collided in the eon before ours, they released colossal bursts of gravitational wave energy. These ancient ripples would leave permanent, circular imprints on the cosmic microwave background radiation of our current universe. We are looking at the scars of a past eternity written into the radiation of our present sky. The past is not gone. It is the foundation upon which our current matrix is built. As we piece together all the fragments of modern physics, from the elastic space-time of Einstein to the timeless networks of quantum gravity, the psychological filters of the human brain, and the eternal cycles of the multiverse, we arrive at the final, definitive realization of our journey. Time is not a single, objective thing. There is no absolute clock on the wall of the cosmos. Instead, the universe is a complex matrix of multiple temporalities, all overlapping and interacting to create the grand theater of reality. We live our lives inside a highly specific, local layer of this matrix. We experience time as a smooth, psychological river because our biology requires us to filter out the deeper mechanics of the cosmos. We are macroscopic creatures moving down an entropy gradient, reading a pre-existing four-dimensional landscape frame by individual frame. But just beneath the surface of our daily perception, the true architecture of the universe operates outside our linear constraints. Down at the quantum scale, the universe remains permanently, beautifully timeless. The fundamental loops of force and nodes of probability do not wait for tomorrow or regret yesterday. They exist in a state of absolute interconnected potential. Up at the cosmic scale, black holes twist space and time into knots, creating horizons where eternity passes in a flash, and space swaps its coordinates with history. And in the grand geometry of the block universe, your entire life, every joy, every tear, every triumph, and every quiet thought is permanently etched into the indestructible crystalline structure of reality. You are not a helpless leaf being swept away by a violent river of time. You are an intrinsic feature of a massive, beautiful, four-dimensional sculpture made of starlight and geometry. Your past moments are not dead memories drifting into nothingness. They are as solid and real as the mountains on Earth, permanently sitting in the landscape of space-time. Your future moments are not empty gaps of uncertainty. They are already woven into the fabric, waiting for the flashlight of your consciousness to illuminate their paths. We are the eyes and ears of the cosmos. We are the mechanism by which a timeless universe of pure mathematical probability translates itself into a vivid, beautiful, and emotional story. The illusion of time is the greatest gift the universe could have ever given us. It allows us to experience beginnings, to feel the deep beauty of growth, to navigate the complexities of choice, and to appreciate the fragile value of a fleeting moment. When you look up at the night sky, you are not looking at a separate world. You are looking at the grand machinery that generated your own existence. The stars, the galaxies, the black holes, and the quantum foam are all parts of a single, unified information network. And as we drift through this cosmic matrix, marking our local days and years, we can rest in the knowledge that nothing is ever truly lost. The universe does not forget. Every flash of light, every heartbeat, and every cosmic tick is saved forever in the eternal archives of the infinite grid. To understand how the universe holds on to its history, we must look closely at the vacuum itself. In the older days of science, the vacuum of space was thought to be a vast, empty nothingness, a sterile stage where matter performed its kinetic dance. But modern quantum field theory has exposed a deeper truth. The vacuum is not empty. It is a highly active, dense matrix of quantum fields that possesses a strange property known as cosmic memory. Every time an event occurs in the universe, whether it is the collision of two gargantuan black holes or the firing of a single neuron in a human brain, it leaves a permanent imprint on the local quantum fields. When a massive star accelerates through space, it generates gravitational waves that stretch and compress the fabric of spacetime. Long after those waves have passed, the geometry of space does not return perfectly to its original state. It remains slightly shifted. This is known as the gravitational wave memory effect. This means that space itself is a recording medium. The vacuum acts as a massive, non-local hard drive that logs every kinetic movement, every thermal exchange, and every energetic flash that has ever occurred since the dawn of inflation. The universe does not require a conscious scribe to record its history. The record is automatically written into the very geometry of the grid. Every cubic centimeter of seemingly empty space is packed with the overlapping ghost signals of a billion historical eras. If we could build a sensor sensitive enough to read the microscopic state of the quantum vacuum, we would find that the past is entirely accessible. We could read the birth of our sun from the residual ripples in the local fields. We could trace the movement of every atom that formed the Earth. The linear flow of time appears to destroy the past only because our macroscopic senses cannot detect the subtle, permanent alterations left behind in the subatomic matrix. This archival property of the universe shifts our understanding of identity and existence. We often feel like fragile, temporary sparks that appear in the cosmos for a brief moment and then disappear into eternal oblivion. But if the fabric of spacetime retains a flawless, geometric record of every particle interaction, then your existence is a permanent physical fact. The specific arrangement of energy and information that constitutes your life is indelibly stamped into the universal ledger. You are a permanent fixture of the cosmic architecture, frozen into the memory of the vacuum forever. One of the most fascinating features of our universal matrix is the absolute speed limit of information, the speed of light. We treat this speed, roughly 300,000 kilometers per second, as a property of light packets, or photons. But physics tells us that this speed limit has nothing to do with light itself. It is a fundamental property of the spacetime fabric. It is the maximum speed at which causality can propagate through the universe. Why does this limit exist? To answer that, we must look at how mass interacts with the cosmic grid. In the quantum world, particles that have mass cannot travel at the speed of light. As an object accelerates, its kinetic energy increases. Because energy and mass are equivalent, as described by Einstein's equations, the object effectively becomes heavier in terms of its resistance to further acceleration. The closer an object gets to the cosmic speed limit, the more energy is required to push it faster. To reach the speed of light, an object with mass would require an infinite amount of energy, which is a physical impossibility. Only particles that are completely massless, like photons and gluons, can travel at this ultimate speed limit. And because they travel at the speed of light, their relationship with time is completely broken. From the perspective of a photon emitted by a distant star 13 billion light-years away, there is no journey. The photon does not experience time. It does not age. The exact microsecond it is emitted from the core of that ancient star is the exact same microsecond it enters your eye on Earth. To a massless particle, the entire history of the universe happens instantaneously. This creates a beautiful mass paradox within the cosmic matrix. The universe is split into two entirely different modes of existence. On one side is the world of mass, the world of stars, planets, brains, and rocks. Because we possess mass, we are trapped inside the slow, heavy mechanics of spacetime. We are forced to experience the linear sequence of moments, the slow crawl of seconds, and the painful separation of distances. We are bound to the ticking clock. On the other side is the world of pure energy, the world of massless radiation. This world exists in a state of absolute, eternal simultaneity. The entire cosmos, from the Big Bang to the final heat death, is experienced by a photon as a single flash of unified reality. Mass is the anchor that drags us down into the illusion of time. If we could strip the mass from our atoms, the prison of linear time would instantly dissolve, and we would find ourselves existing everywhere and everyone at once. As we explore the fluid, elastic nature of time in the cosmic matrix, we inevitably run into a major structural crisis, the crisis of causality. In our everyday experience, causality is absolute. Cause must always precede effect. The match must be struck before the fire can ignite. The parent must exist before the child. This logical sequencing is the foundation of all science and all sanity. But once Einstein proved that there is no universal now, and that time can be stretched and warped by gravity and speed, the strict rules of causality began to fray at the edges. If two events happen far apart in the universe, Different observers moving at different speeds will disagree on the sequence of those events. To observer A, the star exploded before the planet formed. To observer B, the planet formed before the star exploded. To observer C, both events happened simultaneously. This is not an optical illusion caused by the time it takes light to travel. It is a literal disagreement in the geometric structure of their local realities. Einstein solved this crisis by introducing the concept of light cones. A light cone is a geometric boundary in spacetime that defines what events can causally affect another. If an event sits outside your light cone, it is physically impossible for it to influence you or for you to influence it. The cosmic speed limit protects the universe from logical contradictions by keeping distant events isolated from each other's causal chains. However, when we introduce the extreme distortions of general relativity, such as spinning black holes or theoretical wormholes, the geometry of light cones can become so radically twisted that they loop back on themselves. Mathematical physicists like Kurt Gödel discovered that certain configurations of the universe allow for the existence of closed time-like curves. A closed time-like curve is a literal loop in spacetime. If you were to travel along this path, you would move forward in your local time, but the geometry of the universe would guide you back into your own past. The existence of these loops triggers the famous paradoxes of time travel. If you travel into the past and prevent your own birth, you create a logical contradiction that breaks the grammar of reality. To resolve this, some physicists turn to the many worlds interpretation of quantum mechanics. This theory suggests that the universe does not possess a single, linear timeline. Instead, every time a quantum event occurs, the universe splits into multiple parallel branches, creating a vast, ever-expanding multiverse of alternative realities. In this framework, if you travel back along a closed time-like curve and alter history, you do not change your own past. Instead, your action causes the universe to branch into a new, parallel timeline. The matrix of multiple temporalities is far larger than we ever imagined. It is a grand, infinite tree of branching histories where every possible path, every alternative choice, and every variation of cosmic evolution is playing out somewhere in the vast quantum landscape. Linear time is just a single thread in an infinite loom of realities. Our journey through the cosmic matrix brings us back to where we began, to the fragile, fleeting, present moment. We have seen time stretch near black holes, dissolve into the quantum foam, and reset itself at the absolute boundaries of the multiverse. We have forced ourselves to accept that the clean, linear river of time we feel in our daily lives is a beautiful biological illusion, a grand translation constructed by the human brain. But this realization does not diminish the value of our existence. It elevates it. You are not a helpless observer being swept away toward an empty graveyard of heat death. You are an essential part of an indestructible, four-dimensional masterpiece. Every action you take, every word you speak, and every dream you pursue is permanently etched into the eternal architecture of spacetime. The past is not gone, and the future is already waiting. We are the universe looking back at itself, transforming raw mathematical probabilities into a living, breathing history. Our lives may be a mere blink in the cosmic scale, but within that blink lies the consciousness that gives the cosmos its meaning. As the stars continue to burn and the cosmic web continues to expand, we can move forward with a profound sense of peace. In the eternal archive of the infinite grid, nothing is ever lost. Your story, your light, and your footprint are written into the fabric of reality forever.